On This Week in Enterprise Tech, your big data is a gas, your traffic gets encrypted, and we're going deep on packet inspection. Twiet on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiet, This Week in Enterprise Tech, episode 67, recorded November 18th, 2013. Deeper packet inspection. This Week in Enterprise Tech is brought to you by RingCentral. We do everything in the cloud. That's why I love my cloud-based phone system by RingCentral. Zero startup costs, and RingCentral is $20 per month per user. Try it now with a 30-day risk-free trial and buy one desk phone and get a second phone free up to 20 phones. Call 800-543-9980 or visit ringcentral.com and use our promo code TWIT. And by Ting.com. Ting is a mobile phone service that makes sense. Save money with Ting, pay for what you use, doesn't require a contract, and offers unlimited devices on one account. To save $25 on your first Ting device, visit enterprise.ting.com. That's enterprise.ting.com. And by GoToMeeting with HD Faces by Citrix. The powerfully simple way to meet with coworkers and clients from anywhere. Share the same screen and see each other face-to-face with HD video conferencing. Even present from an iPad. Try it free for 30 days. No credit card required to get started. Visit GoToMeeting.com, click on the Try It Free button, and use promo code ENTERPRISE. Welcome to Twiet, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballas, the digital Jesuit, your guide to all things in the enterprise. But I'm not guiding you alone. No. I've got a fantastic crew of characters, starting with my good friend, Mr. Brian Chi, the director of the Advanced Network Computing Laboratory in Hawaii, and all-around geek in paradise. Brian, how are things going from your hollowed-out volcano in Hawaii?
Oh, things are going great. I'm a little depressed because I was on a Kickstarter for the Nomiku sous vide cooker. And I was so looking forward to doing sous vide pork tenderloin. But unfortunately, it was dead on arrival. But shout out to the Nomiku guys. I had a return label within 2 hours. So awesome.
A Kickstarter that actually understands customer service. You know who else understands customer service? Mr. Curtis Franklin from Enterprise Efficiency. Curtis, you're on the right coast, and it seems like you're surrounded by a lovely shade of green.
Oh, it is green, lovely November here, so things are cool. It's a little gray outside today, but hey, this being Florida, we do need the rain. Just enjoying time here, enjoying finding new stories about executives to put up on enterprise efficiency, but hey, it's always a good Monday when I can be here with the Twiet crew.
Indeed. Good Monday indeed. And you know what makes it a good Monday? Green data centers. That's right. I've said it. The secret's out. Let's talk about our first Enterprise Bite. We've got a couple of stories talking about how some major players are making the move to green data centers. Now, this is not new. We've had every company from Apple to Facebook to Microsoft talk about their green data center proposals, about technologies. Apple actually introduced their data center, which they said was 100% green, but it really meant it was 100% green because they bought credits to take away from their dirty power. Now we actually have some big players who are saying, no, we want to have our data centers entirely powered by clean energy. The first one is, I got to say, this is one of my favorite stories. Microsoft is researching the possibility of using fuel cells to power their data centers. They're talking about doubling the efficiency of their data centers. Now, they're talking about right now their new data center in Cheyenne, Wyoming. The DC will be powered by methane. There's a big wastewater treatment plant right next to the location. They're going to be pumping methane out of the, what do you call that, the biodegrading waste products, putting it into a 300 kilowatt hour fuel cell and using it to power all the servers in their data center. It's clean because, as we know, a fuel cell doesn't actually burn it. It uses a catalyst to split the hydrogen out of any gas you give it, be it propane or methane. In this case, it's methane. And then it combines it with oxygen to make water, heat, and electricity. It's a fantastically efficient process, especially if you're pulling the gas out of a waste product like poop. That's right. I'm just going to call it now. It's poop. Now, here's something that's even cooler. They're talking about the next generation of their data centers already, and that means that they want to move away from having a huge 300 kilowatt-hour fuel cell into thousands of 10 to 25 to 7 kilowatt-hour fuel cells inside the racks themselves. Now, Cheebert, I want to throw this over to you first. We've heard about this idea before of moving the power generation as close to the servers as possible because that increases efficiency, right? How does it increase efficiency?
Well, anytime you start transporting electricity over distance, even if you're using really efficient superconductors, you still lose some power along the way. So if you decrease the distance, you decrease the amount of power you lose. Of course, it has some problems, and Microsoft has definitely acknowledged that. Data centers are not exactly the safest place on the face of the earth, and putting in what is potentially an explosive gas into the racks could be a problem. But then again, no worse than pumping water in, because there's a lot of people talking about also using water-cooled servers in the data center. So it's just going to take time, and it's going to take some effort, and it's going to take some people working with safety experts.
Right. Yeah, there's definitely a lot of question marks that have to be sorted out before they use this technology on a large scale, where you actually have each rack with its own set of fuel cells. But there is a lot to be said about the efficiencies that you get when you're not making all those transitions. Let's take a common transmission line from a hydroelectric dam, which is pumping out a few kilowatt hours per generation unit. Now, that power has to be stepped up, turned into AC, transmitted over a bunch of lines, which then stepped back down, where it may then go into a transformer station, which will turn it into lower-powered AC, which will go to a data center, which then gets stepped down again before it goes to the racks, where it gets turned into DC and fed into the servers. What we're talking about here is a power generation technology that could potentially go straight from methane to DC into the servers. Curtis, there's not going to be an immediate ROI on this. I mean, it's more expensive to generate power this way. But long term, do you think the enterprise understands, beyond just the PR implications, but the benefits to having green power generation in these huge data farms?
Well, I think that when it comes to green power, there's a lot of questions, because let's admit it, aside from the PR value, there isn't a huge incentive in most locations to do green power. Now, it's entirely possible that Microsoft or some of these other companies could work out some sort of carbon offset-based rebates or special incentives with a state government. That's certainly possible. And frankly, I'm thrilled to see someone who is looking seriously at capturing and using methane, because it is a fairly potent climate change gas. This is exciting. It is early. I think that it's a good thing because it is one step in the right direction. A lot of people keep looking for the home run, the one technology that's going to replace big point generation power plants. I'm not sure we're going to get there. I think that having a bunch of different options is valuable. This is one of them. My only real question is this. If some of the biodiesel that use recycled French fry oil have exhaust that smells like French fries, do you really want to be in a place where you're using poop gas to generate your power? The exhaust could be an intrusion deterrent, I suppose, if nothing else.
No, wait, that's a red herring, because we all know that the exhaust from a methane fuel cell is carbon dioxide and water, so data does not stink. Now, Cheebert, I want to throw this back over to you, because this story brings up an interesting, concept that a lot of people I don't think understand about data centers. When we think of data centers, when we think of the servers that are inside of data centers, all the appliances that you're going to need in order to make it run, we kind of think of it just scaled up from the stuff we've got at home. Yeah, it's more expensive. Yeah, it's more powerful. But you plug it in and you go. This story also brings out the necessity to tailor every data center for the local power conditions. In other words, not every data center is going to be in the same band of power usage requirements. Not every data center has a grid attached to it that's going to be able to provide it the same voltages, the same amperage. And so you really have to sort of tailor each data center for whatever the local grid can feed you. Another aspect to this story is that if you're using these methane power cells, you have everything in the rack. You just have to give it gas. You don't have to worry about conditioning power, adjusting it up or down. As long as you get it, it's fuel, you're good to go. What could that do for both these large installations and installations that might be mobile?
Oh, God, sorry. Give it gas and go.
That's show title.
Dude, the problem is, right, it's going to take some time to get there. Yeah, obviously, data center designers are going to need a lot of different tools in their toolkit. Just keep in mind that Yahoo and Google and a bunch of other folks are already using bloom boxes up on top of the buildings or on the side of the buildings. In fact, I've actually been pricing it out to power the Hawaii Institute of Geophysics because, shall we say, we've had some really unreliable power. Just ask the people that use my mirror site. But we actually have a lot of natural gas in pipes because we're a university campus, and that goes into the spigots on the desks. And when you're starting to talk about 42 cents a kilowatt hour for power in Hawaii, all of a sudden the natural gas starts making a whole heck of a lot of sense. And that's the reason why folks like Yahoo and Google have taken a good hard look at it, especially in California, where the power cost has the potential for being really high. And they've already seen the fact that during a really bad time where they lost some power generation and tried to buy it off the grid, their neighbors in neighboring states started jacking up the price of the power, which is very bad for a data center that's a very large consumer of power.
Yeah. Well, let's move away from the theoretical into something that has actually been built. Well, almost built. Facebook is talking about green data centers as well, but they want wind power. Yeah, sure, maybe fuel cell might be pie in the sky for them, but they want something they can build now. And they're talking about opening in 2015 a brand new data center in Atlona, I'm sorry, people from Iowa, with a wind farm right next door in Wellsburg. Now, this will allow them to supposedly take 100% of their power requirements from a green energy source. Now, I want to throw this over to you first, Curtis, because this seems like a PR stunt, but Facebook has been one of the players that has consistently come back to the alternative energy well, looking for ways that they can make this work. Is this a viable strategy? I mean, we know that it's more expensive for these green power sources. We know it's more expensive for them to make data centers that could actually use them. What's the payback for them?
Well, I think you get the payback in several directions. And one of the things that we have to keep in mind is what we've seen right here. When you go with renewables, especially something like wind, it does play with every aspect of your data center design, including siting. Now, that's not really surprising. We've seen data centers sited near dams and in places where power is inexpensive. So that's not new, but it is something to take into account. I think that where they get their payback, though, comes...
Oh, I think Curtis just got caught up in a wind farm.
Sorry about that. In terms of reliability, this is something Brian referred to in his last response. If you talk to the people who are in charge of things like critical infrastructure, we know that there are a lot of vulnerabilities in our nationwide power grid. And I think that we're seeing Facebook, Google, and some of the other big data players start to look at ways of insulating themselves from possible breakdowns in a national power grid. Having your own power generation source, having it green, having it right there at your data center does a pretty darn good job of providing you with power security along with everything else.
Okay. Chibert, I want to ask you a question about wind power, hydrothermal power, geothermal power, whatever it's going to be. A data center would seem to be the ideal customer for these alternate power sources, because one of the biggest problems has always been this idea of, well, the power grid waxes and wanes. It has different demands at different times, and so it's always difficult to match up demand with when these alternate power sources are actually putting out their power. A data center is pretty much going to draw the same amount of power at all times. It's going to be running all the equipment at all times. So a wind farm that's spinning 24 hours a day or a geothermal plant that's putting out power 24 hours a day would, well, it's sort of matched up for a data center, right?
Matched up, yes, but not in the technology. Keep in mind, the wind is not always blowing at the same speed. The sun is not always shining at the same levels. There are things called clouds that do a really good job of shading photovoltaic. So you start getting into, I've got variable amounts of power, but I do have a predictable amount of draw. So what it does is it makes it a little easier for the power companies to do predictions, because turning on a, say, a gas-fired turbine isn't just flicking a bic. Those turbine rotors are so big and take a good chunk of time to heat up that Hawaiian Electric in Honolulu actually is the #1 employer of chemists. They don't flick a bic. They actually add chemicals into the mix until you get ignition. And that way you get a very gradual heat up so that you don't go and warp your rotors. Thusly, you know, firing up a turbine sometimes can take hours. And that's why you want predictable power. So that's good. But I wish photovoltaic in wind was just as predictable.
Yeah, predictable power. Now, when we come back, we're going to be going into a deep dive on, well, deep packet inspection. But before then, I want to take a moment to talk about the first sponsor of the Twilight Riot. And you know them, you love them. It's Ring Central. When we built this brick house, Leo decided that we were going to dog food. He wanted us to do all the stuff in the cloud that we were telling people they could do in the cloud. So our email is in the cloud. Our scheduling is in the cloud. Our document sharing is in the cloud. And when our IT guy, Russell, I told you I was going to talk about him, came up to us and said, hey, look, we could have a full-featured phone system without the PBX and bulky equipment in the basement, well, it was a no-brainer. We love Ring Central. There are zero startup costs. There's no PBX hardware to install or maintain. Ring Central allows us to customize all of our call handlings with the click of a switch. Now, our producers get their voicemail through their email, and we can get all of our fax messages right on our smartphones. Ring Central also offers the ability to send and receive faxes straight from your email, PC, smartphone, or tablet. New faxes will arrive in your email inbox, so you can always stay on top of your business. You can preview and print faxes, design cover sheets, and even sign faxes electronically right from your computer. You'll never have to use a bulky fax machine again. Here's what we would like you to do. We would like you to try Ring Central to see if maybe it's what you need for business success. Ring Central offers all-inclusive pricing as low as $20 per month per user. You can start right now with a 30-day risk-free trial, and they have a special offer for my listeners. When you buy one desk phone, you get a second phone free, up to 20 phones. So call this number, designated for my listeners, 800-543-9980. That's 800-543-9980. Or you can go to ringcentral.com and use the promo code TWIT. That's ringcentral.com, promo code TWIT. And we thank Ring Central for their support of This Week in Enterprise Tech. Let's welcome back to the show, I believe it's his third time on Twilight, Mr. Matthew Gass from Arrowhive Networks. Matthew, thank you for coming back. For the folks who maybe missed your first two appearances, why don't you say a little bit about who you are and who you work for?
Well, first I've got a question for you, which is, given that this is my third appearance, how many times do I have to come on the show before you give me a nice leather jacket?
Well, I'm Catholic and I'm a priest, so I'm just going to say, God will say. God will say. No, I have no idea. I don't know the rules here. Yes.
Well, I've spent the last couple of years at Arrowhive Networks. I'm Director of Product Management, building our operating system as we move from being a wireless company into a general networking company. So that's been an interesting ride, and we now have a full line of networking equipment, which has been a lot of fun for us to build.
Yeah. Now you're here to talk specifically about deep packet inspection, DPI. Why are you a DPI expert if you work for a wireless networking company?
Well, the answer to that is pretty simple, which is that DPI is now accessible to the masses. It used to be something that was very specialized and was difficult to do. And as with so many other things in the technology industry, Moore's Law is a harsh mistress. It both gives and takes away. And one of the beneficiaries of the increasing amount of computing power is basically anybody who uses anything electronic, because this allows us to do much more sophisticated packet handling. So when I started off in Wi-Fi about 10 years ago, it was enough to just get people's bits over the air and move them from a mobile device through an access point onto the network. Now there's much more emphasis being placed on doing intelligent things with those bits as they fly across the network. So it started off, we looked at quality of service for applications, and that's all fine and good, except that the main way that we've identified applications traditionally, going all the way back to when I started off in technology working on firewalls, we did it by TCP port number. And somewhere along the way, everybody realized that every application should run over port 80, because that way it got through firewalls.
I like that. Actually, so we've seen an organic growth of 802.11 Wi-Fi. And you're absolutely right. In the early days, it was cool just to have that connection, just to say, oh, look, I can access blah, blah, blah from over here, and I'm not connected to anything. But now we expect more out of wireless. We expect something more akin to a wired connection. We want that reliability. We want that durability of connectivity. So naturally, you're going to need to use tools like DPI in order to find out what's going on the wire, on the line, on the wireless link. So let's get into DPI. First of all, what is deep packet inspection? What does it mean?
Well, the original packet inspection technologies we used were simply looking at the header. You can look at the IP header, you find a source and a destination address. You can look one level deeper at the TCP header, you get things like sequence numbers, you get port numbers that identify individual applications. And going all the way back to the dawn of routers, it was possible to write rules that would do filtering based on these. And you can say, if you're going from this IP address to this IP address, drop the packet. Or if you're going, if you have a connection that's going from the inside to the outside, it's okay, but the only packets that are allowed back into the network are things that belong to an established connection. And there's a bit in the TCP header that allows you to do that. And these are all unencrypted features in the packet headers. So it's very easy to write filtering rules. You would write them in order, and basically you start going down the list, and the first time you find a rule that matches what you have, what you're looking at in terms of the packet, you apply that rule, and it might be to accept the packet and let it on, or drop it. But it's a very raw set of capabilities. It's very crude, because just because a packet says it's established doesn't mean it actually is. And just because a packet says it's a particular application doesn't mean that it corresponds to a port number. And this is something that we saw with the increasing emergence of web-based technologies, is that almost everything that people care about runs over port 80. So you look at a typical enterprise network, and the IT department will be trying to deliver a whole variety of applications. And if you say, well, my conception of the rule that I want is I want my employees to be productive, so they need to access important tools like Salesforce to access our customer accounts, possibly looking at an enterprise resource planning system like NetSuite, which is a hosted ERP system. So those are important applications, but Facebook games are not. And if you look at the packets that comprise all of these applications, what you see is that they're all going to a web server. And so therefore they all look the same to these traditional filtering rules. So we need to look into the packet in much more detail to understand what's going on. And that's why it's called deep packet inspection, because you're looking at more than just the headers, you're looking at the content. This does require a lot more effort to be expended by whatever is processing the packet on every packet that goes through, because you're looking at maybe more than one packet in context. You're looking at tens or dozens of packets as they come through and build up an established connection. And that's what allows you to say, well, although this is port 80, I can tell the difference between something that is business critical that I want to accept and maybe prioritize versus something that is not very important and I'm just going to drop on the floor.
Now, how exactly is this different from what we've done before with, say, Wireshark? Here on Twite, we've had a couple of episodes dedicated to tapping and to analyzing traffic. We've looked at VoIP traffic. We've captured those streams. We've been able to play back streams of HTTP traffic. We've been able to look at DNS entries to find out whether or not people know where we're going on the internet. Isn't that deep packet inspection?
Well, so that is certainly a much deeper level of packet inspection than you would get from a traditional header-based rule set. And much of what we wind up doing with all this computing power is we're able to create the ability for a networking device to be the equivalent of an expert. So could you do a form of deep packet inspection by plugging in Wireshark and hooking up a computer and an analyst to look at every flow through your network? Well, absolutely you could. But on any network of any size, the brain power of an analyst and looking at every connection that might be going through your firewall, it's not possible to do that in real time. So what we're doing with DPI is we're going through the same process of saying, well, based on what I see, so I've got ports, I've got message contents, I've got packet size distribution, I have DNS names, so I might look for a DNS lookup before a connection is established. I'm going to take all that, put it together, and that's going to give me a really good picture of what the application actually is. It's nothing that can't be done by a human, but you have to do it faster than a human ever could in order to make it into a useful tool for IT administrators. Because if the end goal is for them to say, you can't do Facebook on company time, they can't afford to have somebody sitting and looking at a wiretap and authorizing every connection or not. It has to be done in pretty much real time by the network itself.
Now, we're starting to get reactions from the chat room, and I love this because our chat room, there's some really, really smart people, and there's some enterprise professionals who always keep us on our toes. And they are, well, absolutely saying, look, this is just Wireshark, right? This is Wireshark with a good GUI. This is just Wireshark on steroids. This is nothing that I can't do with my own Wireshark setup with a 10-cent tap. But Cheebert, I think it stands what Matthew just said, which is, yeah, anyone can do deep packet inspection if you're willing to sit there and look at all the traffic running through your network. For you, someone who's actually at a university campus, that's not humanly possible, right? I mean, you could have a team of interns. You still wouldn't be able to sit down and have them analyze the packets like a DPI tool can.
Oh, of course not. And, you know, Matthew's point about we've got more processing power in the devices is pretty apropos. You know, what else are we going to start doing with it? What else can we automate? What else can happen without human intervention? So let's flip this argument a little bit on its side and say, hey, I've got a major retail firm that wants to be able to go and find out where the heck people are congregating in their store. They want to know when the people actually come from the outside to the inside. How long do they stand in front of the picture window? Or you're a library and you want to find out where the heck, you know, where are your patrons standing? Well, my wife and I attended a library conference recently and found out that one of the things that libraries are forced to do because they don't have the tools is look at dust bunnies in front of the shelves. So wouldn't this be a great thing to be able to do with deep packet inspection and being able to find out where people are, what they're doing, and you know, it's not quite so big brother as retail analytics. I want to be able to provide better service to you in a shorter amount of time with less human intervention so I can make it more cost effective.
Right. Curtis, let me throw over to you for a second here, because I've noticed a trend at the last couple of interrupts that we always have vendors who are offering their DPI tools. There seems to be a lot of interest from executive level types who are looking at the tools and saying, okay, well, can you tell me if my network has blank? And then can you tell me if my network sees blank? Is there more of an awareness? Have you covered anything on enterprise efficiency about DPI and why it's actually becoming more popular?
Well, we haven't done a lot about DPI specifically, but we have looked a lot at the issues that have led to the interest you saw from the executives. And I put it down to two things. One is an increasing awareness of things like industrial espionage. People want to know who is moving stuff in and out of their network and what kind of things are moving in and out of their network. The other piece of that comes from the regulatory side. The regulators in various industries, whether it be healthcare, financial services, or just those that affect publicly traded companies, have finally succeeded in scaring executives about being responsible for what kind of information people pass in and out of their organization. And so what they want is a cost-effective, absolutely reliable way to know whether their organization, and by extension, them sitting there in the executive office, is vulnerable to a regulatory complaint. They want to know if they are liable to prosecution and fines from regulators because of what their employees are doing. Giving them the answer to those questions is what DPI is able to do, and being able to automate that, make it dead reliable, dead certain, and oh, by the way, much less expensive than having an army of analysts is what the executives are really interested in.
I had Carl Auerbach, who once told me, look, DPI is all about never having to tell someone I don't know what's going on my network. That's what it comes down to. That's what the automated tool can do. It can look at every packet, it can look at every stream, it can look at the big picture and at each tiny little header and beyond at the same time and tell you, look, this is the kind of traffic, this is the kind of activity that's taking place on your 10,000 seat enterprise class network. Matthew, I want to go back to you. Let's get to the brass tacks. Let's say I wanted to deploy a DPI tool on and we always use the 10,000 seat enterprise class network. That's our hypothetical situation. What would I need? What's the equipment? What are the tools? How do I have to build it in order to make it most efficiently and effectively let me look at traffic?
So I think you're absolutely right to go back to what you said about DPI means never having to say you don't know what's on your network. And a big part of the interest in DPI is that you get to see your network evolve in real time. So a few years ago, for example, it was always a joke. I see so much YouTube on my network. Is this really something that's important? And something that I've seen happen in the last few years is that YouTube has become a teaching tool in K through 12 education. It's much easier to use somebody else's website to set up video. So a big part of what DPI helps you do is understand and plan for your network. So you may have 10,000 seats, but those 10,000 seats aren't going to use the network the same way today that they were a year ago, and the way they're going to use it in a year from now is probably also different. The last time you had me on the show, we talked a little bit about 802.11ac and how that was driving increased traffic volumes. So understanding how the network is being used points to an important application of the way that you might choose to use one of these tools to help understand and plan for increased capacity in your network. And in terms of what you need to buy, it depends on your use case, really, that you can use DPI all throughout your network. It might make sense at the firewall, where you want to be very clear about what applications are allowed out. So rather than using the traditional rule of saying everybody who is on the inside of a network is allowed to go outside to any website, you might choose to look more granularly at the websites that they're going to and to enforce a particular set of standards on what they're allowed to do in terms of allowing for an acceptable use policy or preventing certain complaints. It's also possible to bring DPI deeper into the network so that you can put it rather than at the outer border edge, you might use it at the access layer. So in that case, you are saying, I have the same policy because I have the same desires about what I'm trying to do. But at the access layer, it might be more about prioritization and efficiency so that you understand, okay, these are the applications that are coming on this on-ramp to the network. And so therefore, I want to make sure that important things are prioritized. And that's more important in, say, Wi-Fi than it is with wired links because you have relatively limited capacity. So you'd be using DPI to say, not just voice deserves priority because it's voice and it's important, but you can say certain types of video are important and deserve priority, or maybe even certain applications that are typically best effort. So I wouldn't normally think of prioritizing web traffic, but maybe I really want to prioritize web traffic to salesforce.com. Or if I have a sales team that depends on using GoToMeeting or WebEx, I might prioritize that over other applications so that this critical business function of helping my company relate to the outside world is then prioritized. And these are all, coming up with a policy is individualized. It's what's on your network and what's important. And sometimes you see a bit of a cycle where a DPI tool is put in the network and it's used to help you figure out what's on your network, as you said, to stop saying, I don't know. Now that I do know how my network is being used, I can go back and prioritize appropriately. And that might depend on who's doing it. It might depend on the time of day. It might depend in, say, K through 12 on a class schedule, that certain classes are allowed to use the network in certain ways and others are not. So based on the initial idea of what you had about how your network is being used, you then check that against reality, that now you have a way of knowing exactly how your network is being used, and you can adjust technical policies appropriately, because the high-level policy you're trying to implement should never prescribe particular applications. It should be relatively loose in the sense that you say, we're going to prioritize things which are important to our core mission, but we're not going to say, this is obviously part of our core mission, this isn't. That's something that you would define on an evolving basis.
All right. Now, when we come back, we're going to get past all the theoretical, we're going to get past all the philosophical issues about DPI and actually show you how it works. But before we do that, I want to make a pause for the second sponsor of the Twilight Riot, and that's Ting. Now, you might be asking yourself, what is Ting? I think the easiest way to think of Ting is that it is a no BS mobile service. They are an MVNO, that's a mobile virtual network operator, which means that they resell the Sprint network that you already know, that's already loved, that already we know is durable and consistent and reliable. Now, how is Ting different if they're just reselling Sprint service? Well, I'm glad you asked. Because Ting gives no contracts, no ETFs. They are truly and completely contract-free. They don't charge you any BS service fee if you want to leave your contract because, well, they know that that's not what you want. They actually even have a new ETF relief program. If you're paying an ETF to another provider, Ting has your back. They will credit you for up to 25% of your ETF, up to $75 per device. You simply purchase your device through Ting, port your number, submit your final bill with your ETF detailed from your previous carrier, and Ting will give you that money. It's that simple. Go to ting.com/ETF for more information about that part. Now, they also give you no bundling or ride-along services. You're probably sick of that if you use one of the other carriers. Voice, minutes, text messages, megabytes of data, all billed separately so you know what you're paying for. There are no overages, charges, or penalties. You just pay for what you used. And there are no add-on charges. Voicemail, caller ID, tethering, hotspot, three-way calling, call forwarding. Basically everything that should come with your service, Ting gives you as part of your service with no additional charges. There are no mysterious line items on your bill. Don't you hate that when your monthly bill will fluctuate? Well, Ting actually breaks it out for you so you know exactly what you're paying for. Ting charges you for what you use, plus whatever taxes they are legally obligated to collect. They have no hidden charges, recovery fees, or other BS. They also offer you unlimited devices on one plan, which means you get to share pooled minutes, messages, and megabytes. Each device on a plan just costs a flat $6 per month. Ting also has a powerfully wonderful online control panel. You get to take control of your account, your usage, and your bills in one place on the web. And if you don't like that, they have a no-holds customer support line. You can call them at 1-855-TING-FTW anytime between 8 a.m. and 8 p.m. Eastern Standard Time, and a real person will pick up the call and talk to you. If you don't want to talk to a person, you can find their excellent online support at their forums at help.ting.com, where they have an active customer support forum, a simple and powerfully wonderful help ticketing system, video tutorials, startup guides, and much, much more. Now, you might be asking yourself, well, Father Robert, how does Ting work? Well, again, I'm glad you asked because, well, first you purchase your mobile device from Ting, which you will receive within 2 to 5 business days. Then you activate your device with Ting, and you have the option to select a new phone number or port an existing one. Ting will break out your rates by minutes, text messages, and megabytes, and bill you at the end of the month just for what you've used. How refreshing is that? So here's what we want you to do. We want you to try Ting. Visit Ting today at enterprise.ting.com. That's enterprise.ting.com. No, seriously, right after the show, go to enterprise.ting.com. You can save money and better manage your mobile phone usage with Ting. And you can check out their savings calculator to see exactly how much you or your company can save. This Week in Enterprise Tech viewers also save $25 on their first Ting device when you sign up. So visit enterprise.ting.com today and start saving now. And we thank Ting for their support of This Week in Enterprise Tech. Matthew, we've had enough of the ivory tower. Let's get into the down and dirty. Show me how this deep packet inspection works.
Well, and you've hit right on the head of something that's very important, which is that it's all fine and good to say, we do this deep packet inspection, we're able to figure out what actually is in your network, but telling you about it in a way that makes sense is really the key of making this into useful technology. So I'm going to show, not surprisingly, some screenshots and a live demo based on what we have going on at Aerohive headquarters right now.
Whoa. This is a live demo?
Yep.
And you're going to show us what's going on at your headquarters?
I am.
You are a brave man.
Well, you know, when you get right down to it, what's the easiest product for me to get? Well, it's right here on the screen.
There we go. Aerohive. Yep. All right. Hit it.
So we are looking here at the dashboard, and so this shows you what's going on our network right now. So over here on the left, we've got our devices organized into groups, and if you scroll down, you see that I've highlighted Sunnyvale, California, which is the incredibly interesting city where we are headquartered. And we've got a couple of buildings there, so I've said I want to look at all 3 buildings in context, so I've grouped them all together. And you can do any of what I'm about to do by looking at any of these device groups. So you can choose to look at everything in a city, you can choose to look at individual buildings within the city, and you can choose to look at floors within the building or even individual APs. Now, if we were to look at, say, the 10,000 seat enterprise, looking at something like that, having these containers to look to look at what's going on helps you up level and see in a larger scale about how the network is being used. So you can say, all right, what does it look like at headquarters? And that's what we're looking at here. So you have over here on the right, you have a pie chart of the individual applications. And if we look at, say, this big wedge over here, we see that the #1 application is CIFS. So no surprise there. In an enterprise network, a lot of people wind up doing things that look an awful lot like file sharing. And that's how many companies choose to move files around and share files between users. So if we wanted to look at the biggest users of that, so we know that this is one of our top 10 applications. We're just going to go ahead and we'll click on that little wedge. And so in this case, we drilled down, we've gone into details of the application. So there is a report about what the application is. Now, many of your viewers, of course, already know what CIFS is for. You can see the top users of this particular application. You can look at usage over time. You can look at the SSIDs that are using the application. So if you wanted to think about how the usage is divided up between different classes of network, so in this case, not surprisingly, anybody who's doing enterprise file sharing is on the Aerohive employee network. If we were to look at some other application, we might see usage on both the employee and the guest network.
I do want to point out, because this question has come up in the chat room, oh, well, I could see all this stuff on Wireshark. But no, not really, because the data that you're showing that your tool is actually breaking out shows a lot of applications that may be flowing over the same ports, but it's got the intelligence to actually look beyond the header and say, no, this comes from this application, this comes from this application, this is from this site, this is from this site. So again, there's that built-in intelligence that you're talking about.
Right, and so as an example of that, if you go and look at the top 10 list of applications, SIFS is the #1 application, but you go down the list and you see
iTunes.
YouTube, you see iTunes, YouTube, Apple,
Netflix.
Google, and Google Video. Now, many of these applications are going to run over the same port. So we're able to break that out. And one thing that's obviously nice to see here is that we don't have a lot of employees on Facebook today. I'm sure the CEO would be very pleased by that.
Although he'd probably be wondering why Netflix is on there. Although 0 bytes, within the last 7 days, 5 gigabytes.
Right, and so it's common for people to take a break at the end of the day. I recently visited a school that was a residential school. It was a high-tech school for an entire state. And what they said is that the usage of the network went dramatically up after the end of class, and the application mix shifted very dramatically at the end of the day, which again, there's no particular surprise there. Yeah. The other thing that a tool like this does that you can't necessarily easily get from looking at taps is that it allows you to correlate everything that's going on the network. So if you move between devices, if you have multiple devices, so as you drill into a particular user, you'll see the contribution from each of their devices. So when I'm in the office, you'll see entries under my main user account for what I'm doing on my laptop, which is my primary computing device in the office. But you'll also see contributions from what I do on my phone and my tablet. And I use all of these devices in different ways. And so therefore, you'll see that maybe if the application mix is different on different devices, that you need to provision them differently. Or if you're seeing a lot more tablets come in, this might show you in advance what's going to happen to your network over the next year as employees start to use the network differently.
We've got a good question from Johnny B in the chat room. He wants to know if this tool let me narrow down by time frame. So can I say, look, just show me what happened on my network between 2 a.m. and 4 a.m. because I want to know who's working late. And can you actually show me how you would drill down on an individual user or individual device?
Sure. So to look at an individual time frame, on the dashboard here, there's a time duration right across the top. So it's 1, 4, and 8 hours and a day, or you can have it be, you can choose to have it be custom. So I'm looking at the 8-hour timestamp just because, in my experience, you have to have enough data to get an interesting result. To look at an individual user, all of these things are linked. So just as I clicked on a particular application that and then saw the top users for that, you can click on a particular user. So let's look at the very top user, and we'll see
now we're getting dangerous.
We'll see that most of what this person is doing is file sharing. And then you can go down and you see WebEx, HTTP, Arrowhive Mail is a service that we define to look at our own mail server. And you see that there is that most of this particular user's application usage is on file sharing. And there's one device which is presumably a laptop running Mac OS X. So this actually isn't that interesting a user to have looked at because he or she is using the network appropriately to do the job.
Can we look at your traffic?
No, because I'm not in the office right now.
Oh. But can we look back? How far back can this tool go?
Well, so how far back you can go and how far back you can go on our demo network where we regularly run the latest code and reset the database are two different questions.
Right.
And just as you here at Twit work to eat your own dog food, so do we. Mm-hmm. And that means that the amount of data that we have to look back depends on what we're trying to do with our network and how much data we have in the database going back. And oftentimes it's a priority for us to be shaking out features and bugs. And so therefore going back, and I've been out of the office for a while. So last week I was taking a trip in South Carolina to visit some customers there. The week before that I was in Vancouver for the IETF, and a couple weeks before that I was in Brussels. So sometimes my network utilization actually isn't that interesting because I'm not always in the office.
Got it. Now, Matthew, let me give you a hypothetical situation here, just like we did during the theoretical segment. That is, if your CTO was to come over to you and say, we're seeing funky stuff in the network, we have people complaining that they can't access X and Y, what would you show them? I mean, show me on your tool, what would you give him to explain, okay, this is the kind of traffic that we're seeing, this is the kind of uses that we're seeing, this is what we've seen over the last 24 hours. Explain, run through that scenario and show me how you would use that tool to sort of defend your network.
So it depends on, again, on what type of reports you're seeing. And there are many ways that people will report, hey, the network doesn't work. That you might start off by looking at just the amount of traffic. So looking at the top applications by usage gives you an idea of what people are doing. So is that number going to be substantially bigger than it typically is? So can you tell if there's a flood of data on the network? Something else that you might then look at is, as you go down that list, are you seeing an outsized contribution from applications that you know need to be prioritized and are set up to be prioritized? So if we were to see a large contribution from our video conferencing system, that's something that we might want to look into. And that's where having everything tied down to individual users is valuable, because having gone in, we see that this application is of interest to users. We can click on it, we can see the top users of that application. Then we can say, all right, so in this case, is there something about the way that they're using this application that we didn't anticipate? Can we find that out? Or is that something where rather than it being a new use of the network, this is something that we would need to then configure a policy around? So you mentioned Netflix earlier. If we saw a lot of Netflix data, we might then go and create a firewall rule. So those rules are written just like the traditional firewall rules would be written in our tool. You create a firewall rule, but rather than defining a port, we'd already defined that the action that you take as acting against a service. So you can choose to act on port 80, or you can choose to act on a service like Netflix. And it's possible to then apply bandwidth limits. So you say, well, you can run Netflix, but you only get a limited amount of capacity. So rather than getting a couple of megabits per second, you only get, say, 128K, enough to get a catalog, but not enough to look at a big video stream and swamp the network.
Right. Now, I want to cut back to you in just a bit, because we've got people in the chat room asking, how would they use this to protect against malicious software, malicious behavior on the network? But before that, I want to go around the horn really quickly. Start with you, Curtis. Again, coming from the executive enterprise angle here, how valuable is it to have a single pane of glass like one of these tools, where you're not just showing a bunch of traffic and saying, okay, well here, we see that, but actually have graphs, to actually have a drillable interface where you can say, this is where the network's being used, this is who's using it, this is what applications are most popular, this is how much traffic has transited in the last 24 hours.
I think from the executive perspective, where all of these things are important is when they allow you to make best use of your employee time. If you can be effective and efficient with the employees you've put on the desk monitoring the output of your program, then it's worthwhile. As Carl said, you quoted Carl Albrecht some time ago. You want to do this because you never ever want to be able to say, I don't know what's happening on the network. If you can say, I know precisely what's happening on the network, and do so in a cost-effective, efficient manner, then you've got a win. Then you've got something that executives are happy to pay for.
Let's go over to you, Chibert. Again, since you run your own network and since you do a lot of work with the university, you see a ungodly amount of traffic. You do need a tool like this, and I'm not going to say that that Aerohive is the only company that provides real-time management, deep packet inspection tools. There are plenty of others that work quite well, but one of the things that goes across all of these tools is the ability to better manage your network. How do you use DPI tools in tweaking how your network is set up?
You know, actually, I'm going to answer your original question first, and that's why would I want a single pane of glass? Well, that's actually pretty easy. I want something that I can watch across the room that might catch my eye, because I don't, unlike a lot of corporations, I don't have a dedicated NOC. I have maybe a portal, or I might have maybe a monitor. The more functions I can combine onto a single pane of glass, the more effective I'm going to be, because then as I'm walking by, say heading to go refill my coffee, or look up after I've finished something, I've got a better chance of actually seeing it. At universities, one of the problems we have is seeing the forest from the trees, and having deep packet inspection and the ability to have that 10,000-foot view really makes a huge difference in being proactive about things. Just like a major corporation, a university has customers. Unfortunately, these customers sometimes have, shall we say, issues. And they yell and they scream and they get really pissed off when things don't work. So having that 10,000 foot view of a single pane of glass makes a huge, huge difference. And being able to have multiple tools tied together makes a big difference too. So deep packet inspection is a way of life. You might as well embrace it. And gee, isn't it better to know about the problem before the phone starts ringing? And that's really what deep packet inspections is all about.
Matthew, I want to go back to you for one last segment. The first thing is a question, again, out of the chat room that's talking about your solution. There are many solutions that are appliances. There are many solutions that are services that get installed on your VMware server. How does the Aerohive system work? And then back to the question I asked you before we did the round robin, and that is, how would you use your DPI system to look at, diagnose, and then prevent malicious behavior?
So the first question is pretty easy, which is, how does this work? There's a DPI engine that we run on each of our networking devices. So as traffic goes through an access point, every packet is being sent to a DPI engine, and then the results of that are being reported into our management system. So that allows you to do the analysis and the statistical work separately and in a centralized place. And that's how you correlate what you see from all the access points. That's what makes it very easy to follow a user from AP to AP and see their overall network usage. For the second question about using it to monitor for malicious behavior, a lot of what you're able to do with deep packet inspection is because you're able to define malicious behavior much more clearly in terms of applications. You can do things like rate limit or block certain applications that you expect to be problematic, and you're able to cut down on malicious behavior before it even starts. So to go back to Brian's point, and I'm sure that as a university network administrator, he has seen far more malicious behavior than I ever will in the corporate world, that we know what a lot of this looks like, that there are certain things that just aren't productive and you don't want them being used. Sometimes because they're not productive, sometimes because we know that they're bandwidth hogs. That it's, for example, it's really important to limit BitTorrent utilization because there are legitimate uses of BitTorrent in terms of things like distributing free software. But for the most part, that's not a way that you want to see your network being used. And you've got two ways to deal with it. One is to try and figure out who's using BitTorrent, call them on the carpet, and provide appropriate discipline. Another way to deal with it is to just make it too difficult to use for the malicious purposes you have that you're trying to prevent, so that you never have to get to that escalation step.
Right. I got it. And so If you were to offer one piece of advice to anyone who was trying to set up a DPI tool on their network, aside from the fact that it's wonderful to have it baked into all of your Wi-Fi appliances, what would it be? What are they looking for? What should they be shopping for? What kind of capabilities need to be baked in out of the box for them to even consider it?
So what you're really looking for is the ability to learn about what's on your network and build a policy. And the more integrated that policy can be throughout your network, the more valuable it is. So what you're trying to do is to remove any uncertainty you have about how the network is being used. So you want to be able to conceptualize a fairly high-level policy about what good use of the network looks like. You want to be able to monitor usage so that you can look for compliance with that. And once you've done that, then move to enforce that through whatever mechanism that you have built into the equipment. So does the equipment support you translating that policy into a set of very concrete actions that the packets will be subject to as they traverse your devices? So can we block applications? Can we rate limit applications? Can we do this based on users, locations, times of day, where they are in the network? So putting fences around particular areas, so you're allowed to use an application in this area of the campus but not this other area. So does that map into the types of access controls that you're trying to build on your network?
All right. Well, right after the break, we're going to come back and do a quick wrap-up of Deep Packet Inspection. But before then, I want to say thanks to the third sponsor of the Twilight Riot. And of course, that's Citrix and GoToMeeting with HD Faces. Now, you know that feeling you get when inspiration strikes, especially when it strikes at weird times. It's in the pit of your stomach. It's in the back of your head. It's that aha moment when you know this is something I need to flesh out. I need to talk to someone to. It's part of the inspiration of business. And we do need our coworkers, our colleagues, our friends, our customers to be able to flesh out that inspiration into something that actually equals business success. But it's not always easy to meet with people. Weird times, weird places, people are out of position, out of schedule. So if you have one of those aha moments and you need to see someone face to face, that aha moment may just pass you by, unless, of course, you're using GoToMeeting with HD Faces by Citrix, the powerfully simple way to meet online. With GoToMeeting, you can connect, brainstorm, and collaborate instantly. The moment you get that aha moment, you can dial someone up. You can invite them to a meeting and talk about it. Wherever you are, or wherever your team is located, from any computer, smartphone, or tablet, a meeting is nothing more than a click away. You can share screens to work with other people on documents, spreadsheets, and projects in real time. And just turn on your webcam and boom, you've got an HD video conference. It's just like meeting in person. In fact, I love it because you get to see the facial expressions. You get to see that raised brow. You get to see that frown. You get to see if they understand what you're talking about, if they're on board, or if you need to explain it more. It's so much better than just talking to someone over a conferencing phone. Now, I'm not just a spokesperson for GoToMeeting. I'm a customer. I actually use it. My work has me meeting with literally hundreds of coworkers and colleagues each month. Now, I used to jump into a plane every time I had a meeting because, well, that's the accepted way of getting face-to-face time. I switched to GoToMeeting with HD Faces, and I haven't looked back. Not only has it cut my travel time per month in half, but it has allowed me to have more interaction with the people I need to collaborate with the most. I love GoToMeeting. It's easy to use, and with HD Faces, it's just like meeting in person. So here's what we want you to do. We would like you to try GoToMeeting. Start hosting a GoToMeeting in seconds from your computer or mobile device by signing up for a free 30-day trial. And yes, there is no credit card required to get started. You just visit GoToMeeting.com, click the Try It Free button, and use the promo code ENTERPRISE. That's GoToMeeting.com, promo code ENTERPRISE, and we thank Citrix for their support of This Week in Enterprise Tech. One quick wrap-up, because we really are out of time here. There was an interesting story that broke last week about the IETF, that's the Internet Engineering Task Force, which I believe, Matthew, you're a part of, so don't tell us anything you can't tell us. But at their meeting in Vancouver last week, they were talking about the standards for HTTP 2.0. And one of the topics that was broached was including heavy, strong encryption within the standard. Now, they're not talking about end-to-end encryption, right? We're talking about data center encryption?
Well, the IETF has traditionally been very concerned about privacy. And to call myself a member of the IETF means that I've joined a mailing list or two. It's a very open organization, and it's very easy for anybody to join any of the work that they're interested in. I think the best way that I heard it put was that during the IETF, there were plenary meetings where the entire group gets together. And typically, plenary meetings are not the most interesting part of the meeting. You go to particular working groups. But at the meeting in Vancouver last week, or the week before, I forget which, it all runs together when you travel as much as I do, there was a plenary session on the security of the basic internet protocols that was incredibly well attended. It had an all-star cast of speakers, and it was being talked about all week to the point where somebody said, you know, it's unusual that the most interesting session at the IETF is the plenary, and it really was a call to action to think about how security can be incorporated into every protocol in development, given what we know about threats to the internet architecture.
Now, you've already got big players like Yahoo and Google saying that they're going to encrypt data within the data center so that even if you have a device listening in the middle, it won't be able to actually do a deep packet inspection of any of the traffic. But there was another strain of thought that was saying, wait a minute, why don't we do end-to-end encryption? And I know there was a murmur at the IETF. It was kind of shot down because how do you inspect traffic if it's all heavily encrypted?
Well, you don't.
Okay, good answer. Thank you very much. Thank you for coming to try. No, but seriously, I think there's more to that, right?
Well, there is. And that we have to distinguish between what encryption is doing and what we want to do with our network. So if you are to look at a number of network technologies, you might have multiple kinds of data going through a given session. So for example, if you take one of our sponsors, you take Citrix, they have a technology that allows you to virtualize a desktop. Well, not all the packets in the session, which of course ICA is encrypted, not all the packets are created equal. That when you're transmitting screen data, that doesn't have the same requirement as when you're doing a Skype session, you want to get the voice packets over to your remote desktop. So there certainly is potentially an interesting development here where you could define, say, a framework where protocols are allowed to define how they need to be prioritized without necessarily allowing the contents to be well understood. And we have little bits of that already, that the IP hop behavior can be customized by using the diff-serve code point, the DSCP value. And that is something which is outside and in the clear and which we use in Wi-Fi to determine prioritization. But incorporating something like this into our application protocols so that an application can self-describe, even as it's encrypted, what's important and what's not.
What's important and what's not. Let me go again one more time around the horn. Chibert, let's start with you this time. When we start talking about encryption end-to-end, we talked about this at Interrupt before and how it would basically break all of our networking tools. In the pre-show, Matthew spoke to me about this potential solution where you would put something on the outside of the encrypted wrapper just to let the tools know what kind of traffic it was. For example, a voice packet would say, look, I am voice, please prioritize me. Now, that's kind of on the honor system, but kind of not too, right? Because even if the traffic is encrypted, if it's identifying itself as, say, VoIP traffic, we know what VoIP traffic should look like and what it shouldn't look like, even if it's encrypted, right?
Yeah, you bet. And there's already a lot of vendors that encrypt their voice traffic. It's usually an opt-in type of thing. Their login process is encrypted, but the payloads are not. But you can opt in to encrypt the entire data stream. In those cases, what they're already doing is they set diff-serve bits. So like Matthew was saying, there's an external piece outside the encrypted wrapper to describe to the switches how to handle the traffic. That way they get stuck into the right VLANs, right prioritization, yada, 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 blah, blah. It does work. And in fact, when we start getting into the IPv6 world, it starts working even better. And I should point out that a lot of modern machines actually have encryption engines built into the NICs now. It's not something that's hard to do. Back in the day, the chat room reminded me about that. There was a thing called the Clipper chip. It was a great idea to have strong encryption capability in each workstation. Unfortunately, it was badly implemented. So we're starting to get there. We're starting to get back. The Clipper chip fiasco put us back a few years, but I think we're going to get there, and I think the hardware is up to the task.
Okay. Curtis, last words from you, again, from the executive side, looking at encryption, looking at deep packet inspection, and how it's a hot topic right now. Everyone wants secure communications. Do you think executives, do you think enterprises are ready for what's going to have to change in their network infrastructure and what's going to have to change in, say, their acceptable use policies in order to implement encryption?
I think the answer to all of those is no, Padre, because frankly, most executives want what isn't possible. They want absolutely rock solid, unbreakable encryption for all of the corporate data, while they want their security people to be able to look at and identify everything that all of their employees are doing, and especially anything that one of the bad guys might be doing. There's a lot of education that needs to take place, not only with what's possible, but in what the cost is going to be, not just in the dollars that are spent, but in what it does to performance, what it does to your employee needs, what it does to the technology you've got to put in place. The key for the IT department today is to have all of their facts straight so that they can start that education campaign, show them what they're already doing and where it can lead. This isn't over by a long shot, but IT departments that are smart can take advantage of the raised sensitivity to issues like encryption and get some real wins for the security of their organization going forward.
Well, folks, you've done it again. You've used up another perfectly good hour listening to the best dang podcast in the universe. That's right, 9 out of 10 dentists agree. But I want to thank my panelists for being here. Again, fascinating discussion about deep packet inspection and a little bit about encryption right at the end there. Let's start with you, Chibert. What should the Twilight Riot know about what you're doing, where you're going to be, about what you're working on?
Well, what I am actually doing right after this is going to try and see if I can fix some nitpicky little problems on my video wall. While I love HDMI, I absolutely go crazy because of the HDCP key exchange. So every once in a blue moon, my Blu-ray player goes off into Never Never Land and will not display on my video wall, which is driving me to drink.
Womp womp. Copy protection fail. But you know who isn't a fail? Curtis, what's going on at Enterprise Efficiency? That's definitely no fail.
Well, I appreciate that, Padre. What we're doing is continuing to try to tell the stories of senior IT executives. If you're one of those executives and have a story that would be interesting for us to tell, or if you're just willing to talk to me about what you're doing and how you do it, please drop me a note, either a direct tweet to at KG4GWA, or drop me an email message, franklin@enterpriseefficiency.com. I would love to talk with you. And right after this is over, I'd love to figure out why my cabled network is less reliable than the Wi-Fi today. Got a little troubleshooting to do.
Yes, you do. Good thing we've got some Enterprise geeks. Matthew, thank you so very much for coming back. It's always a pleasure to have you and Aerohive on the show. You do bring a lot, especially from angles that maybe we don't expect. Can you tell the Twilight Riot a little bit about where they can find you, about what Aerohive is working on? Tell us, what do you want us to know?
You can follow me on Twitter at Matthew S. Gast. I am also a regular blogger for Aerohive, which is where you can find out about all of the interesting stuff that I'm doing. I do owe the world a description of my most recent trip and what it was like to visit one of the top high schools in the country for science and math.
Yes, and by the way, one of his biggest bona fides is that he's Dr. Simon Tam in Ingress. He fights for the resistance, and yes, we will save the world from Shaper influence. I also want to thank you. That's right, you, our listener, our viewer, our watcher, our loyal audience member. Thank you for watching Twilight each and every single week, because you let us geek out about the stuff that we think is really important in a connected world. And so we want to do something for you. The first thing we want to do is to give you a place where you could get every episode of Twiet automatically downloaded into the device of your choice. If you go to twit.tv/Twiet, you will find a drop-down menu where you can select to have our episodes dropped into your iPad, your iPhone, your Android phone or tablet, your laptop, your Zombie Zune. Any way you want it, we've got it, and we'll give it to you. Also, drop by our YouTube page at youtube.com/Twiet. There you will find not just all of our episodes, but you'll find our individual segments in case you wanted to learn up about stuff my IT guy says, about what's going on in the data closet, or about the latest pro gear. Again, all for you at youtube.com/Twiet. Also, why not follow me on Twitter? I've seen in the chat room that people are complaining that it's hard to get a hold of me. It's really not. Just hit me on Twitter. Follow me, message me, and I'll get back to you. It's really the best way to get a hold of me because, well, I'm always running around doing things for Twit. Also, did you know that we do this show live? That's right, here in this studio, at this very desk, every Monday at noon Pacific time. If you drop by live.twit.tv, you'll be able to find not just the episode, but everything that goes on before and after. It really is the best way to watch Twiet because you get to see how the sausage is made. And as long as you're watching us live, why not jump into our live chat room at irc.twit.tv. There you will find some of the funniest trolls, some of the brightest people on Twit, and yes, some just imaginary friends who call themselves mods. I'm pretty sure they're bots, but hey, there they are. Finally, did you know that we've got a TV survey going on right now? If you go to twit.tv/survey, you'll be able to tell us how you consume Twit. It's important for us because it lets us know how we should be shaping our schedule and our content so you can best consume it. I want to thank Cyberdog in the chat room, Karsten, my super producer, and Jason, my excellent TD. Oh, Jason, by the way, who runs a show here on the Twit network. Jason, what does that show talk about?
Android. It's called All About Android. You talk about it every week, so I'm surprised you don't know at this point.
I got really bad memory. I got really.
Yeah, but you know, you mentioned it before the show, so I'll go ahead and show off. If you didn't subscribe to the show that's called All About Android, soon you'll be able to play a video game called All About Android.
No way.
Yeah, there's a little video game being produced right now by one of the fans of the show, Matthew Holtzum, an endless scroller complete with NFC and Project Loon power-ups. And Google Glass.
Okay,
Yeah,
see, now I'm jealous.
pretty
Wait.
sweet.
Why do you get a video game? I mean, can't Twiet get a video game?
I think we all deserve. There we go. I think we all deserve video games around here. Around this piece.
Oh, and by the way, I do need my product cam now because there is one more thing that we need to show to the Twiet Riot, and that's this. You may not have purchased Jason's new CD, but if you did,
I haven't even seen
how
this.
about that? You got one of these limited edition cover arts.
That's so funny. I have not even seen this in person.
Yeah,
so
man.
I'm gonna have to. You are unveiling it for me too.
Twiet, we do it for you. That's because we love you.
Pre-orders for that album are actually going up tomorrow.
Absolutely. Now that's it from here from the Twit Studios in Petaluma, California. I'm Father Robert Ballalis here, reminding you, if you want to know what's going on in the Enterprise, just keep Twiet.